Okay. Hi, Tarun. So let's start the linked list program that we are going to discuss. We did a couple of problems in linked list last couple of weeks. So last week we did this one, right? Finding a loop. Did you get a chance to look at that algorithm?
Yes, sir.
Yeah, finding a loop and the entry point of the entry node of the loop. That's very good, very important algorithm. I think it is one of the algorithm in that cracking the coding interview book. Okay, very interesting one. So next one is I think this is also good one. Linked list merge two linked lists. This is merge sort. I don't know whether you practice a merge sort or not. It is a merge sort algorithm. Okay. So how can we do with the linked list? Write a method to merge two sorted linked list into a single sorted linked list. We are going to discuss that. So let me show you the. Did you get a chance to look at this Geek for Geeks link?
Yes, I have gone through the
Oh, you gone through it. Okay. So
questions.
you got some idea on the algorithm as well.
Yes,
Very good, very good. Then we can go further. We can go faster. So I don't know what method they followed. Mostly the same approach they followed. Let's see. It's still opening here. So basically, two linked list will be there. We need to create the final linked list. Okay. The given linked lists are sorted. We need to create final linked
we need to
list,
create
which is also
sorted final.
exactly, exactly. So the final linked list is also must be sorted. So we'll start. So here is the thing. So auxiliary given to sorted linked list n and m. So one could be n m elements, another one is m elements, respectively. The task is to merge both of the linked list in place and return the head of the merge linked list. So this is important. In place means we should not take um, another linked list. You should not create another linked list, or we should not take another data structure. I disable my what happened. This continue without stopping. Okay, this is the problem. I disabled the ad blocker. Now they are saying ask me to enable it. So let me open the link in a different browser probably. So you gone through the algorithm, right? So how do you do? So rather than while I'm opening, explain the process. How do you match the two link list? What is the approach? Hey Sunil. Hello. Hey Sunil, welcome to the class.
Excellent.
Good morning.
Hi Sunil. Good evening for you. So where are you? Are you from Hyderabad or you joined before, right? I think I remember.
Yes, sir.
Are you from Tirupati? That's Kumar.
Yes, sir. Yes, sir.
No, you are the one, right? Kumar. Kumar is right. This is the one, right?
Yes, sir. Yes, sir. Me only, sir.
You only. I'm trying to map. Very good, very good. So how is the practice going?
Yes, sir. I didn't get that.
So how the practice is going? Are you practicing
Hello,
with
sir.
yourself?
Yes, sir. Yes, sir.
Very good, very good. Okay. So did you get a chance to look at the algorithm which I shared, like magic of the link?
Yes, sir. I will see, sir.
Okay. So the question what we are going to do is this one. So we have uh, two sorted linked list. Okay. Right method to merge two sorted linked list into single sorted linked list. So how can we do that? Okay, so somehow the pages are not opening for me. It's taking very long time. I disable my, so let me disable block enable on this side. Disable. Okay, so I disabled my ad blocker. Okay, now it's opening. So uh, how do you match the two sorted link list? Go ahead and explain your thoughts, Tarun or Sunil.
Sorting the linked list
Yeah, yeah. How can we do that?
and then creating a new linked list and
Yeah, that is the brute force way, right? So they
adding those.
given the linked lists are
Hmm.
sorted. See, we you no need to sort the input linked list. The input is already sorted, right?
Yes,
Yeah. So how do you going? How are you going to sort the final? Create the final sorted linked list. So this is the main algorithm. Did you gone through this algorithm, Tarun?
yes, sir.
So there are multiple ways.
Take an array
Okay.
and added the elements in the array and sorted the array and then created a linked list.
Yeah, that is a good way. But the problem is you are taking auxiliary of size n plus m, right? So let's take an input here and try. So 5, 10, 15, 2, 3, 20. Okay. 5, 10, 15, 2, 3, 20. 2, 3, 20. Okay. What happened? Sunil dropped. So did he put a message or something? Anyway, that's fine. It is automatically coming from my phone charge. What happened? So let me ask him join again. Okay, let's go. So this is the input list, right? Tarun, 5, 10, 15, 2, 3, 20. So we need to create final linked list like this 2, 5, oh, sorry, 2, 3, right? 2, 3, 5, and then 10, 15, and then 20, right? This is the final linked list. Okay, the given linked lists are already sorted. So how do you do this? They so one thing you said is you will put all the numbers in an array and then you sort it in the array, right? So here the space, this is like a n, this is m, let's say, right? So you are taking n plus m extra memory, isn't it? Hi Sunil, you rejoined. Sunil, can you see my screen now? Hello? I don't know. So he's just dropping and
think
joining.
some network issue.
Maybe some network issue. Yeah. So anyway, so currently you understand, right? So you are taking extra memory, and also it is like once you take an array, again another order of analog n is the least sorting algorithm time complexity. So you are increasing the space and you are increasing the complexity also. So can we do it in place? That means without using extra memory. That is the first question. Okay.
Mm.
Let's think in a real life example. Okay, this is in a school. Let's say this is in a school in a assembly line. So every day people used to gather in the school, right? In the morning we will pray. So that's where, let's say, two lines are there. Okay, one line with all the according to their height. Okay, so short people on the short, like in the beginning, and longer people will be in the last. The same for the same line. This is line A, line B, right? So you want to match the two lines. What you do? So here is a short part. Like, you got my idea, right? In a real life.
Yes,
So this is exactly the same
we are
question.
going to link the last node with the head of next column.
Last node with what? So like this. So we have people like this. Okay. And here is one more line with like this. People with different heights. Okay. Now we need to match these two lines. People stood in one line. This is a people standing in another line. So how can we match those two lines? That is the question, right? Again, is asking for Zoom meeting. Kumar, I'm recording, Kumar. So I think this is better. You join in this link only. So maybe join from PC. Okay, it is working fine for everybody. I don't know why you are getting a problem. Sunil, join from computer. So Tarun, you joined through computer, right?
Yes, yes.
Yeah, Sunil, you also joined through PC. Then you will be able to see it because I'm recording the thing. Like Zoom will not allow me to record, and there is a time limit also. Okay, so we'll continue the algorithm here in the meantime. So what we do is, so we need to match all the people in the final single line with with based on their height. Okay, what you can do, Tarun, so you can simply ask, like you can look at the first guy here, first person here, who is the smaller, you will put on the first, isn't it? Now, so let's say this guy is
Yes.
smaller. You already removed this one. So now you will compare this one with this person, right? Then who is smaller, you will put that. So wherever you put the small person, you increment to the next node, and you compare with the first next available node in the other linker list, isn't it? So here you are not taking any extra complete empty line, and at the same time you are processing as you go. So basically, of course, in this situation, you are putting aside, you are putting in a separate line. In a real life, you pull them into the separate lines. But here in the link list, what you can do is you can manage the links. What I'm saying is, see, so we need to create final link list. Let's say that is the final link. This is head one, this is head two, and here is the H is the final head of the final link list. Okay. So now what we are going to do is this will point to the short element of those two elements. Okay. So what we do is something like this. Small of 5 comma 2, these two elements, whatever is the small, it will be linked to that. Okay, so now head is pointed to which element? Head points to which one is smaller, 5 and 2?
Two.
2. So head pointed to 2. Now what we need to do is we know head pointed to 2. Now head dot 2, that means 2 is pointed to 3 right now. So 2 is pointed to 3. But
Yes.
we don't know there could be another element. Okay. We don't know whether, see, we selected this element. Now 2 is pointed to this element and 5 is still here. We still need to process this element. Now we don't know which element is smaller unless you read the values. So now 2 needs to point, instead of pointing to 3, 2 needs to point to whichever is the smaller. Let's say these people are holding each other with the hands. What we do, we pick the small person here. Until now the small person is linked to the next taller person in this line, but this person need to um, hold the hand of the next small person, right? Next small person is here, so he needs to hold the hand of this person, right? That will be determined based on the height of this person and this person, isn't it? So what we do is, what I'm saying is head dot next equal to head dot next equal to. So now whichever is the smaller. So we took the 2. Now we already processed 2. So 5 still be here. So next 2 dot next 3. Basically like this. What we do is, again we will call the same method. Small or merge. Let's say the method name is small of, we will say it's a recursive method. Small of, we already processed 2, right? So next 2 dot next is small of 5 comma 3. We don't know until you process, right? Next whatever is the smaller, that will be the next point.
Yes.
So 2 will be pointed to the small of these two nodes. That means 3. So 2 pointed to 3. Now 3 will be pointed to small of these two nodes. Which one is smaller? 5 and 20.
3 is small.
3 is smaller. So no, 5
5.
and 20. We process 2, we process 3. Now 3 dot next equal to 3 dot next equal to 3 dot next to small of this 5 and small 20. Which one is smaller? 5 and 20.
5 is small.
5 smaller. So 3 dot next becomes 5. Now 5 dot next equal to 10 and 20. Small of 10 and 20. So basically it's a recursive, we are recursively solving. Okay. That is the program they are saying. Okay, let me explain you here. Merge two sorted linked using dummy nodes. The idea is to use a temporary dummy node as a start of the linked list. The pointer tile always points to the last node in the result, so appearing new nodes is easy. These people are this is the algorithm that process from the last. Okay, so let's look at the next one. Probably this one we are talking. Using recursion, this is the one I'm saying. The idea is to move ahead with the node in the recursion whose node value is lesser. This is the idea. Okay, so we will take only the node with small value. Got it? When any of the node reach the end, that appears the rest of the linked list, that append the rest of the linked list. So let's say this particular one has the first linked list has 3 nodes, and the next linked list has 10 nodes. So you processed D3, right? Rest of the linked list already sorted. You simply connect with them. You no need to process any of the nodes, right? If one linked list is completed, you are done.
Similar to intersection of an array, two arrays.
Exactly. So that's what is, when any of the node reach end of the end, then append the rest of the linked list. That's what they are saying. Okay. So if I show you the algorithm, then you can understand. This is the easiest algorithm. If we if we know the exact algorithm, how it is working, exact logic. Okay, so here is the linked list node, which we already know, data and the next value. Okay, let's see what Kumar is saying. So I'm asking him to join from PC. Yeah, let's see if he join through PC. That's fine. So creating an initial sorted linked list. So what we did is I created a sorted linked list 1, 3, 5, 7, 15. Right. The next one is a second sorted 2, 4, 6, 8, 9, 11. This is also sorted. Okay. I am printing those. Now here is the main algorithm. Merge M1 and M1 and N1. M1 means the first one, first node in the first linked list, right? Which is this one, M1. Okay. And N1 means first node in the second linked list. Okay. Now look at this. This is the boundary condition, right? Let's say if one of the linked list is empty, then next one is the result, isn't it? You got this point, right? So let's say one of the linked list is empty linked list. I will give you a null value. Then second one is the answer.
So it's like we need to return sorted linked list, right?
That's right.
Then
Yeah, we need to return sorted linked list, but second one is sorted, right? So both are sorted.
yeah, yeah,
See, let's say head one is null, then we simply return head two. If head two is null, we return head one. Let's say both are null,
head
so
one.
you return a null again. So no problem. Let's say head one and head two are null. So in this line number 71, we are returning head two, which is also null. We don't care whether the second one is null or not. Now the control comes here, 75, line number 75. If we have both head one and head two, isn't it? This is also not null, and head two also not null, right? Then we will come to this line number 75. Now what we are doing is we created a separate temporary simple. We are not creating any array or hash list or anything. We are creating only one node. Okay, we create a merged head. This is the pointer that points to the head of the final sorted linked list. Okay, merged head is equal to null. We initialized with null value. Now look at this. If head 1 dot data is less than head 2 dot data, so what we are saying is we are checking the first element of the first linked list with the data, basically the data of the second linked list. Which one is smaller? Let's say head 1 dot data is smaller, then merged head equal to head 1. That means the we are taking the that node as the first node. Then what we are doing, merged head dot next equal to, we need to decide if the merged head node point to the next element. How to decide? We need to say merge, calling the same method. Whichever node you took, you are going to pass the next node. Since you took the head one, you are saying head one dot next. Compare with the head two. You got this point? This is very crucial thing. The entire algorithm depends on this line number 78. And of course 81 also. So the else case is if head 1 is not smaller, which one is smaller? That means head 2 dot data is smaller. The data in the head 2 is smaller, then take that one. Merged head equal to head 2. Now merged head dot next equal to head 1. Since you took the head 2, you need to point to the next element. Take the next element of this head 2 and process the same algorithm. You got this point, Tarun?
Yes, yes.
So it's exactly the same way I explained here, right? So basically, this is merged head, MH. I can take like a, so we can do in 5, 10, 15, 2, 3, 20. Okay, let me write it again. Okay, 5, 10. Sorry, I forgot. 5, 10, 15. Huh? for this one. Let's take example here.
5, 10, 15, 2, 3, 20.
Okay. Yeah, just a minute. 1 minute. Yeah, Tarun. 5, 10, 15, 2, 3, 20. Right? 5, 10, 15, 2, 3, 20. This is head 1. Head 1, head 2, right? We call head 1, head 2. Right? In our algorithm, this is head 1, this is head 2. Now we are creating merged head. Right? Merged head equal to, we are comparing which one is smaller. Here 2 is smaller, right? We'll take the 2. Now
Yes.
mh dot next equal to, again we call the same method, merge of, we call the same, next equal to merge of whatever is the next element. We don't know this element yet until we see the value. We haven't seen. We are saying head, in this case head 2 dot next comma head 1. So basically you can think of like this, head 1, so h1 comma h2 dot next, because you are taking h2 value. So now what happens is this 2 dot next will be decided based on the output of this method. So which one is smaller? So in that algorithm, in the second time, what we do is we will take one more. It will take one more small variable. So here, if you look at this one, right? See, there will be another merge head will be created. Basically, this is the recursively we are creating a node, and we will attach that node to the previous node. So there will be another temporary node will be created. Let's say what happens is, again merged head will be created. That merged head will be either 5 or 3, right? Whichever is the smaller. So merged head equal to head 1. So in this case, which one is smaller? Again 3 is smaller, right? So merged head is equal to 3. That will be replaced here. That means 2 dot next becomes 3. You got my point, right? Again 3 dot next will be decided between these two, comparing 5 and 20. Whichever is the smaller, it will be connected to that. You got the point, right? That is the recursive way of doing it.
Yes. Yes.
Yeah. So here is the final answer. The first one is 1, 2, 1, 1, 3, 5, 7, 15. This is the first list. And 2, 4, 6, 8, 9. This is second list. Okay. And here is the final list. దానిలో పడింది దానిలో పడింది ఇది దీని మీద పడింది అంటున్నాను వుడ్ అయితే కాలుతుంది దాన్ని పడితే కాలుతుంది ఓకే యా yeah Tarun. So here is the final linked list. So now here is what is the complexity of this algorithm. Complexity of the algorithm will be order of,
N.
now we have two linked lists, right? We have n and m. So we have in the first linked list
N
we have
plus
n elements, second linked list is, let's say, m elements, right? So how many times we are navigating each linked list or each element?
one time.
Only one time. That means what is the algorithm? Order of
N plus
n plus 6. Very good. So we are taking only one element at a time, this element, and then we are comparing. So we are not navigating second time, right? That is the time complexity. Now compare coming to back to the space complexity. What will be the space complexity?
We are not taking any auxiliary memory, but we are taking a linked list of n.
Of n. We are not taking, or we are taking only one element actually. I think it's order of one. Look at this algorithm, right? So here we are taking additional node here, merge node, right? We are taking the merge node. So every iteration we will take one merge node with a null value, and we will attach the we will uh, we will assign the whichever is the smaller node. If head one the data is smaller, we will assign that node. If head two is smaller, we will assign head two, isn't it?
So like we are changing the links of the linked list.
Yes, yes.
So like we are doing in place.
We are doing in place, but we are taking one node in each algorithm. In each run of this algorithm, we are taking node. I think it's order of one only. I don't think it is order of n. So it is the time complexity is order of one. So we'll check. We'll check in the website. So the time complexity is order of one because we are taking only one node variable,
Node.
right? So we can check here what they mentioned. Let's see. So here brute force way. Let's see the recursive way. Recursive way they explain somewhere here. Yeah. Mm, so do they talk about the yeah, auxiliary starter function called stack place. I think this is yeah, it's not order of one. I was thinking the same thing. So the time complexity is order of m plus n, where m and m are the size of the linked list. This is right. Auxiliary space also we are keep taking one element at a time. So whenever recursion is there, you know that, right? It will take the stack. So it will take the stack under the hood. So
Yeah. Yes.
so whenever you are processing the first elements, if you process the first element, you take one element, whichever is smaller. When you are taking processing these two elements, you took one another element. So when you are processing these two, again
Element to the call stack.
yeah, they are all pushed into the stack. So that's why it is the space complexity is also order of n plus m. Yeah. And whenever that coming back, the recursion completed, one each element will be removed. At the end of the algorithm, you don't take any, yeah, everything will be processed, all the space will be cleared. But we need complete n plus m space. Okay. So I think here we optimized the time complexity, because if you are taking additional array, that will also be the same thing. If you are taking additional array, again that is space complexity is order of n plus n. But you cannot process or sort the elements in order of n plus n. For sorting, it will take extra time. Definitely at least log of n plus n, right? So that is what we eliminated.
And
Yeah,
yeah.
we here by processing the recursively, what we did is we optimized the time complexity. We made it faster, but space complexity is same thing. Okay. So there is one more idea here. Reversely idea involves first reversing both given linked list, and after reversing, traversing both. This is a kind of another idea of reversing the linked list. I don't know how this will help, but this is another idea. So there are a lot of ways to solve, right? This is also same thing. What is the benefit? See, time complexity is same, space complexity is same. Order of m plus n. I don't think we can do anything better than these two. Okay. So that is the algorithm about the first one, the first question. Okay. So next one is determine if two linked list intersect. So this is also very good one. So are we good with the first one? Any questions on the first one?
No, sir.
Very good, very good. Okay. So, shall we discuss the second one?
Yes.
Yeah. So, determine if two linked lists intersect. If yes, return the intersecting node. Intersection is defined based on the reference, not by value. So, here is another. So, did you get a chance to look this one too?
No, I haven't gone.
Okay. Okay, no problem. I will explain. So, this is intersection of two nodes. Two linked list. Intersection is something like this, right? Like one linked list is like this, and there will be another linked list like this. See, this is the intersecting node. Basically, this node, this linked list is always memory locations, right? Basically, these two nodes are pointed to the same memory location address. Basically, the value in the next pointer is pointed to the same address. Got it? So this is intersecting node,
Yes.
and we need to return the what is intersecting node. So let's say the values here A, B, C, D, E, F. Okay, here is let's say K, L, C. Again, same value C, K, L, M, N. So C is the intersecting node. Both L pointed to C, and here B also pointed to C. Right? So here is the head one, and here is the head two. So how to find the intersecting node?
It's look like a little bit tricky.
Yes.
Because like for C next is D, and for M next is C, and for L next is C,
No, for M,
for B next is C. Like,
wait. Um, this may not be possible. So C for C. Oh, sorry. This is not the correct one. So
for B.
actually, this is because from C only one value, right? Only one value can go from C. So this is the thing because the C can point to only one node. C cannot point to two nodes.
Next.
So intersecting.
Yes.
Basically, two linked lists are intersected here. So let me draw a little bit in a different way. So here is the node. Let's say, okay, this is head to L M N. Okay, this is A B C D E F. Okay, this is the first linked list. First linked list is like this: A B C D E F. Second linked list is L M N C D E F. Correct? Right? So
Yes.
this is the intersecting node. From here, look at that. From C, the rest of the linked list is same. Right? There is no difference. From C, once you reach the C, the rest of the linked list will be same. Because the C pointed to the D and D pointed to E and F. So how can we find the linked list? That intersecting linked list. There are multiple ways. Time complexity n1 plus n2, and there is space complexity n1. I think this is not multiple times. Only one algorithm is there. So how can we find this? Any idea? See, let's say if I give
We
something
need
like this.
to check like
Hmm.
the
If
end of obviously the end node will be the
yeah,
intersection with the other linked list.
yes, yeah. Obviously, end node is same, and then there could be another few nodes before and also same, right? Let's say the linked list is like this. Then it is intersected at the last node, right? So these two linked lists are intersected at the last node, correct?
Yes.
This is one case. And there could be another case like this. This is intersected, last node is intersected here. So, but these three nodes are in common, right? So if I give the input like this, so look at this. How many nodes are different here? Only these two nodes are different. These two nodes are different, but this is common. So we want to find this node. If I say these remaining nodes before the intersection both are different, if I say that these two, this intersection happened, this node, and the nodes before the intersection are same, that means here also two nodes, here also two nodes, then you can easily solve this problem by using a technique which I explained before in a previous algorithms. I clearly explained. If I say these, the number of elements here and here same, what we do is we can take, there is a two pointer approach. Did you remember? There is a two pointer approach, p1 p2, right? What two pointer approach will do is
Yes,
start
yes.
start with the same elements, and let's see, is p1 equal to p2. You will compare these two nodes. Is p1 p2 same? No. Then p1 equal to p1 dot next, p2 equal to p2 dot next. Then you compare, is p1 p2 same? No. Then P1 equal to P1 dot next, P2 equal to P2 dot next. Then P1, P2 same? Yes. That means that is, you can return P1 or P2 because both are pointed to same node, right? If you compare data or if you compare node values, if P1 equal to P2, yes. So return P1 or P2 because both are same. That is the answer, isn't it? You got my point?
Yes.
If the before elements, the elements before the intersection are same, we can find very easily. But here, look at the given algorithm. In the given algorithm, these are two nodes and these
Mm, they
are
are not.
three nodes. We don't know which could be. It could be 1,000 nodes here, or it could be only 50 nodes here. There is no guarantee that these two are same. I did not give that input. What you can do is, first we need to find the difference. The actual logic here is, okay, let me find the difference between these two nodes. Basically, here 100 nodes are there, here 50 nodes are there. Now what we do is take the P2, since H2 is longer, take the P2 and process 50 nodes and stop there. Process 50 nodes and stop there. If you know the difference, what you do is you process 50 nodes and stop at that point, then process P1 and P2 at the same time, like this algorithm. Then you will definitely able to meet this, right? If you meet one by one, p1 equal to p1 dot next, p2 equal to p2 dot next. If you process one, if you are taking one step at a time, you definitely p1 and p2 will meet here. The problem with this is, like, if you start this algorithm now, p1 will go further even before p2 reaches this node, right? Because only 50 nodes. After 51 step, you will already reach C. But here, p2 is somewhere in the 50th node or 51 node. It will not reach the C yet. You got my point?
No, Suresh, like, can you once again explain?
So what I'm saying is, so
So
if
we are basically we are finding the difference of two nodes.
difference of two nodes and whichever is the longest linked list, you process that difference. See here how many nodes on the first one? There are two nodes here, and here there are three
Two
nodes, right?
nodes.
In the below linked list stage 2, we have three nodes. Before the intersection, there are three nodes, correct? So what
Mm.
we need to do is, let's process P2, the difference, like 2, 3 minus 2. What is the 3 minus 2 equal to 1, right? So this different number, this difference, whatever is the difference, that many times you jump P2 and get ready. So now P2 is here. Now P2 is at the M and P1 is here, right? Now you are ready to start this algorithm. You got my point? You are at the right place. Both, there is a chance that P1 and P2 will meet C at the same time. Because if you follow this algorithm, right? These are two nodes, these are two nodes. Because you processed the before node. You already processed this before nodes. You got my point?
Yes, yes, got it.
So whenever you are standing at the exactly some k distance, this is a k. Let's say the k is number of nodes from intersection node. So now this is k and this is also k. You are exactly at the k nodes distance from the intersection node. Then definitely these two nodes met will be meet will meet at the intersection node. Then you find the intersection. But now you can ask, hey, how can I find the difference? How can I? There is no input that there are two nodes here or three nodes here. How can I find it? I don't know the intersection node first of all. How can I find there are two nodes here and three nodes here? Like if you start counting, like you don't know that C is intersection, right?
Hmm.
How do you know that this is like this difference? Basically, this three minus two. You did this three minus two is one. We because it's in a board and we had a diagram, we are able to figure out. But if it is algorithm, how the algorithm can figure out that? The idea here is
So
simply
we need to traverse the two linked list simultaneously
okay.
and check when the next value is see both the next values is equal. We need to find the count of nodes in the linked list.
But the problem is, as I said, if you start traversing at the same time, the P1 will reach quicker than P2. You don't know that C is the common node, right? If you know the C is common node, you already found the answer. You got my point? You don't know that C is the common node. That is the main intention of the algorithm is to find C. So if you start P1, P2 at the same time, by the time P1 comes here, you already jumped here. P1 will jump across the C. It will cross because it's a three nodes here. P will be at the D position. When P1, P2 comes C, P1 will be at the D position, isn't it? You got the problem there?
Yes.
So what we can do is we
Mhm.
can find this difference in a different way. What we will do is you simply navigate P1 first completely from start to end and count the nodes. How many nodes in the first linked list? How many nodes? Six. And how many nodes in the second linked list?
Seven.
Seven. Now you traverse the complete individually, you count the nodes. Now 7 minus 6 equal to 1. That is what we need, right? We need the difference. We want to know how many nodes we need to proceed before starting this algorithm, the 2 point approach algorithm. We need to know this and we also need to know which one is longer. Is it P1, P2? Which one is longer list? Because we know the difference, but at the same time, which one is which one is bigger? Like which node is the longer node, longer linked list? Here the second linked list is longer. That's why we will process these many nodes on the second linked list. Which is longer, which is shorter? We need to know that, right? We need to know two things. First one is the number of nodes, and also we need to know the which one is shorter, which one is longer. Once you know that, you process the longer linked list this k number of times. That is the difference. This k number of times you process the linked list and stop there, and then start this two pointer approach algorithm. Then you definitely meet at the intersection. You got the point, right?
Yes, sir.
Yeah, it is a little complicated, but look at the code, you will understand. So if you want, I can explain again next week as well. So let's see, is the same algorithm they explained probably the same thing. Yeah, you look at this intersection point here, and method one simply use two loops. They are saying there is a two loops method here. Look at that. And method two is mask visited nodes. There is another solution where you can mask the visited nodes, like you say it's visited, 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 something like that. So if you mask that, that is also easy. Like basically what you do is, if you're able to add one flag, you say visited, visited, visited. And when you are doing the second linked list, well, you will see, is it visited, is it visited, is it visited? No. When you go here, it's already visited. That means this is previously touched node. Then you can simply say, hey, that is the common node. That is another way of doing it. But if you cannot add any extra thing to the linked list, let's say the linked list node is not in your hand, you cannot add one more, like is it visited or not. You can, if you add that boolean value, it will be easy. But if you cannot add anything, you have given two linked list which you cannot modify, then this is the approach. Okay, look at if you look at here, this is the method 4. Yeah, make a circle in the first linked list.
In the master method also, we are not going to add any elements, right? We are just modifying the array.
In the which one? In this approach, what I explained.
Master method. No, other
Oh, other in the
mask like
masking. Okay, if you are
boolean
mask,
array.
yeah. Okay, okay. Explain the algorithm. We take an array. What we do
So
with
we
this?
are not going to
Mhm. Yeah, if you are taking auxiliary
we are
memory,
going to
you can do
mark
it.
as
Mm. Go ahead. Go ahead.
so we are going to mask the element which are listed in the linked list.
Okay. So you're going to put it in the array. If you put it in the array, how are you going to check it? You don't know whether that list is already there or not, right? It's better to use hash map or hash table. That's very easiest solution. You put each element A, B, C in the hash map, right? So in the hash map or hash tables, and if C is there, like when you are traversing the next second linked list, you have to check, is L in the link, is L in the hash map? No. Is M in the hash map? No. Is N? No. Is there? Yes. C is already there. A, B, C is there. So simply you return C is the intersection node. It's very the simplest solution, right?
By putting in hash map. Yes.
Yeah, but the problem here is you are taking auxiliary memory. You are, let's say if you have 1,000 elements, you are going to take a hash map of 1,000 elements. So how can we reduce the memory usage? That is what we are trying here. Basically, this algorithm doesn't require any extra memory. You are taking only pointers p1, p2, right? You navigated an entire list first time and you found there are 6 nodes, and you navigated second time, and which is you found 7 nodes, and you found the difference, and you also find which one is the longer list, and then you navigate this k number of nodes in the longer linked list, and then you navigate PV using p1, p2. So it's a step by step approach. In this approach, you are not taking any additional memory other than just couple of pointers, right? So that approach will be somewhere described here. There are a lot of see the method 7 is using hash map. There are different methods to solve this problem. I don't know whether the method I did in this algorithm. There will be definitely, yeah, intersection
So
point.
like, what will be the time complex usually like for
Yeah,
first method?
exactly. Let's
It will be
if
like
the first method. So if you use the hash table, right? If you use hash table or hash map, what is the time complexity? Simply order of, let's say this is n nodes and this one is m nodes.
in
Huh? Order of, this is n, when the first link list n nodes,
in
and second one is m nodes. Why it is order of n? Because the order of n to put the things in the hash map, and again you have to navigate the second link list, right? Order of
yeah,
n plus m, isn't it?
order of n plus n.
You have to navigate all the link list of first one. You have to navigate all the link list of second one also, right? Got my point? Because let's say
Yes.
the last element is intersection, then you are navigating all the elements of the second linked list also. Let's say both are pointed at the f value, then you are navigating. In the worst case, you are touching every node of every linked list. So that is the order of n plus m, and the space complexity is also order of n plus m, or at least order of yeah, if you are taking n1, order of n. If you are taking a second linked list, order of m. So you can think of as a longer of long max of n plus m. We don't know which one you take, right? If you take the long one, right, or short of you can take this small one, we don't know. So you are, if you unless you navigate and find out which one is longer, which one is shorter, you don't know. So let's say you are always putting the first link list in the hash table, then it's order of n, whatever is the number of nodes in the first link list, right? Right.
Yes.
So let's find out the complexity of this algorithm, the one I explained here, the finding the difference and 2 point approach. So what is the time complexity? First one, you need to find the number of nodes in the first linked list, number of nodes in second linked list. So order of n plus m, isn't it? First, you are getting all the nodes of n, all the nodes of m. Plus,
Yes.
again, you are started navigating again second time, right? So you navigated different nodes and then you are navigating again. So basically, it's order of 2 into n plus m, which is order of n plus m. Because 2 is not nothing. You are navigating two times. Order of 2 into n plus m. Of course, we are navigating two times. We are basically increasing the time complexity. We are increasing two times you are navigating, but you reduce the space complexity. It's a trade-off basically. If you don't have much space, this is a better algorithm, right? You got the point? But order of space is only
Yes, Suresh.
order of one. So that is the algorithm. I will show you the code right now. This is very tricky, but go through this, you will be able to understand. So there are different steps here. I clearly put the comments as well. So here is the one. Find intersecting node. List one, list two. Okay. If list one is empty or list two is empty, then null. There is no intersection. If one of the linked list is empty, then it is simply there is no intersection node. Step one, find the size and the tile nodes. This is what we need. So why we need tile node means last element. Why we need that? Let's say if the two linked lists are not even connected. So sometimes I will give input like this. These are the nodes and these are the nodes. So if the two linked lists are not connected, definitely the last node will be different. If they connected, right, the last node will be same, right? So let's say this is like this. These
Yes.
two are connected. Definitely the last node will be same. Or even if the both nodes are connected at the last node, this is the intersecting node. Last node is the intersecting node are same. So if the last nodes are not same, that means these two nodes are not intersecting. So that's why we need last node. So here, find the sizes and the tail nodes. Okay. So this is a result. Result is basically a small class I created. This result has two things. It result has tile node and also has the size. Okay. So that is what I'm going to find. Get the tile nodes and the size. So compare tile nodes. If they are not equal, the lists are not intersecting. So I'm comparing, is the tile nodes are same or not. If last node is not same, that means you just simply return null. There is no common node. Okay. Next, step 3. Find the longer and shorter linked list. Okay. If result 1 dot size, we got two results. Result 1, result 2. Right. Result 1 has the last node of the list 1 and size of the list 1. Result 2 has the size of the list 2 and last node of the list 2. Okay. So here is the very crucial thing. If the result 1 dot size less than result 2 dot size, that means which one is smaller, which one is shorter? Shorter is list 1. This is if else condition in C sharp, right? Simple one line if else condition. Otherwise, two. Got my point here? So if the size is smaller than the
Yes,
result
Surya.
one size is smaller than, then we are finding basically shorter linked list and longer linked list. So if the result one is size less than, same thing here. The longer one, which one is longer? In this case, result two is longer. Otherwise, result one is longer. List one is list two or list one. So we found shorter and longer. Next one, advance the pointer in the longer linked list by the difference in the lengths. This is what I explained here. We need to advance. So longer equal to get kth node. Basically, we know the size. So math dot absolute. So we are basically finding the difference of the two linked list, and we know this is the longer node. This is the longer linked list. In the longer linked list, we need to advance this pointer k times. Okay, that is separate. Function I wrote here. Even the get tile node and size is also separate function. So here I wrote something like this, right? Get tile node and size, that is a separate function here. What it does is it will take a linked list, and it will initially we say size equal to 1 if it is not null, and then we put a pointer here, current equal to current dot not equal to null. We increase the size, and we also put the current node is equal to current dot not next. So finally current will be pointed to the last node, and size will return the size. This is small helper functions. Okay, in the interview you no need to write the helper functions unless you have time. So you can simply say I will do this later at the end of the entry. So this is the main algorithm, right? Once you complete the main algorithm, you can write the helper functions. And here is the get kth node. This k is a difference. So you will basically current equal to head. You start with the longer linked list. If k is greater than 0, current equal to current not equal to null, you say k minus minus. Basically, you proceed the difference between the nodes, and that is the kth node. This is exactly what I explained here, right? In the previously, if we, as I said, we have 50 nodes here, 100 nodes here. So this is 50, this is 100. So you process the 100 nodes at the node, whatever is the difference. Let's say this is like 60 nodes here. You process 60 nodes, 60 like 100 minus 60. You process the 40 nodes, and you both start at the same node. This is the k. You got my point? So you process the longer linked list based on the difference. Here is 100, here is 60. 100 minus 60 is 40 nodes or additional nodes in the this linked list. So you process that 40 additional nodes, and you stand at that location. Now this is also 60, this is also 60. Then both will be pointed to exact same node. After 60 nodes, definitely it will be interacted. Intersect will happen at that node. You got my point? So that's the this method will does that. Okay,
Surya, got it.
so that is the step number 4. It is very big algorithm, I know, but I don't think it is easy to write as well. Okay, if you explain the algorithm, that itself is a great thing in the interview. Advance the pointer in the longer linked list by difference. Next one, move both pointers until they point to the same node. This is the two pointer approach I said. This is exactly the two pointer approach. So now what happens here is in the line number 169, both longer and shorter will point to the definitely k nodes from intersection. So you simply say shorter not equal to longer. As long as shorter and longer are not equal, go to the next one. Shorter equal to shorter dot next, longer equal to longer dot next. You are processing at the same pace. Okay, P1, P2. I explained as P1, P2, but here it is shorter and longer. Both are, since you already advanced k nodes, now both longer and shorter are same distance from the intersection node. That's why we can simply say until they equal. Okay, so step number 6, whenever this while loop ended, that means both will be equal. So returns the intersection node. You can return longer or you can return shorter. Both are same. This becomes true, right? So we can use either variable, shorter or longer, because both pointed to the same element. You got it? There are 6 steps here, and we have to do one by one. So this is a very big algorithm, but If you're able to explain well, that really helps interviewer. Oh, you know all these things. It's this is like, I don't expect candidate to write the code. At least they will be able to figure out the algorithm. There are different ways to do it. Even if you say hash table one, interviewer will be happy. Oh, this guy know how to use hash table, right? Or if you explain this one is also good. There is a both are good algorithms. Hash table is like you are just processing only one time, n and m in the hash table, but you are taking n plus m additional memory. But the algorithm which I said, you are processing 2 into n plus m, you processing 2 times, but space is order of 1. So both are equally good. There is no good and bad algorithm. This is good in terms of processing, but bad in terms of memory. But this is good in terms of
Space complex.
space complexity, but bad in terms of processing. It's not that bad.
Thank you.
It's basically it's a trade-off. So if you are able to explain these two algorithms, then itself is like, I will 100% I will be happy with it, because I know if you're able to explain these things, you will be able to write code. If I give you 2 days, let's say, even if you have, if I give one day, you will be able to do it. If you, I know you are not able to do in 20 minutes or 25 minutes, I know, but you know the algorithm, you know what you are doing, you will definitely able to do if I give you one day or 1.5 day without any bugs. I have that, I will get that confidence, right? That is what we need. So if you explain these two algorithms, and if you write even few lines of code, at least like step 1, step 2, or even like step 3, that's fine. I know you will be able to do rest of the things. So that's why the 25 minutes is like that. It's all like depends on how you explain your algorithm and how much you proceed. Okay. Sometimes what happens is you will not be able to find the second this algorithm. If I say in the real time interview, we'll always discuss about this hash table, and you explain this time complexity, space complexity. Then I will ask you, hey, can you reduce this, can you reduce the space complexity? In the real time you may not get the this idea. For any algorithm, if you got an idea, if you will, your mind may not be able to think the second idea. You can
Second
take,
approach.
yeah, second approach is not easy. It's a, we are all humans, we always have the similar mentality. You will say, hey, this is the idea, I don't think there is no better idea, or there could be one, I don't know. Then as an interviewer, I don't want to waste any more time. What I say is, okay, let's start writing the code for this. There's a 50, you will get a, you'll get, yeah, it's not super impressed, interviewer is not super impressed by you, because you will not be, you are not able to find the other solution. But you can impress the interviewer by properly writing this first algorithm. So if you say you don't know the any other idea, then you got only 50% of the score. Now if you able to write this algorithm well, you will get the rest of the 50%, right? So, but if you say these two algorithms in the beginning, you already got 99%, not 100%, at least 90, at least I would say 90% you got, because you're able to explain properly two methods, and you're able to differentiate between the advantages, pros and cons of the two methods. Then I am super confident about you that you have the good data structure knowledge. So I will be super happy. I will put you at the 90% of the score, only 10% for writing something, right? Then I will say, hey, we have just another 10 minutes only, whichever approach you want to write, right? I don't say, hey, write only the second approach. I know this is very difficult one. This has 6 steps. I know you cannot finish in, even I cannot finish as interviewer, I cannot also finish in 10 minutes. I will say, hey Tarun, please explain, please write whichever algorithm you want to write. You want to take first algorithm, okay, write it. So that way, this 10% is just I want to see how you able to code. I already impressed by 90%. You got my point. This is our interview, how the interview techniques and how the interviewer thinks when you are talking about different algorithms. Don't always think that, oh no, I don't know the answer. I could not able to figure out the second one. Don't make yourself down. You will say that at this point, I'm not getting any other ideas, but I'm happy to implement the first approach. You will say in a positive way. Okay. Okay.
Yes.
Awesome. Awesome. I hope it is helpful, right?
Yeah, it's great.
Very good. Okay, I'm going to stop sharing, and maybe I will stop as well, recording as well. I will put these links. You can definitely go through them. So very important, like go through them in the next couple of days so that you don't forget the algorithm. This is very complicated one, right? So it is better if you go through the code at least next in the next couple of days. The meeting is here. Yeah, awesome. Okay, I'm going to stop recording. Stop recording.